All right, looks like we're recording. Hi, everyone. Welcome to the TST meeting. Today is March 15th, 2017. We've got Antonio from CreateNet here today to talk about non-disruptive intent reallocation. But before we get to the main topic, I just thought we'd go through the community acknowledgements. Looks like we've got, it's been a few weeks. The latest one we've got is a shout out to Abdullahim and the Teaching Brigade. They've been stepping up to create open and modular teaching material to help people learn ONOS and other SDN fundamentals. So their, I guess, regular calls are Thursday mornings, so you can join their meetings or their mailing list or Slack channel if you're interested in seeing what they have going on or you want to participate. So thanks again, Abdullahim and the Teaching Brigade. So without further ado, I'll pass the presentation rights over to Antonio and make the floor yours.
Okay, thank you. Okay. Do you see my screen?
Yep.
We do.
Okay, perfect. So, my name is Antonio Marsico. I'm a researcher at FBK CreateNet. And together with Michele, Roberto, and Domenico, we are working on the designing and developing of this non-disruptive intent reallocation. So, let's start on what is the non-disruptive for us intent reallocation. So, we mean moving a path that is currently allocated to an intent to a new one without any connection disruption. So, why we need a reallocation of an intent? Because sometimes for very big networks, network operator may require to optimize the existing resource that they have. So it's important that when they send an intent, this intent can be moved without making any disruption. And why also we don't need to give a disruption to this intent? Because the disruption of a connectivity service must be avoided for the applications that are sensitive to packet losses. So I think about the distributed database. If I have a distributed database between two different data centers, they have a transport network in the middle, and me as an operator, I do a relocation, and this database should avoid to lose their packets. So it's really important also because probably the people that are running the distributed database are paying for this service. And so if I'm doing an reallocation, this service should never be disruptive. So now let's see what ONOS offers to us. Currently, the ONOS intent framework allows the update of an intent with the same key. So if I send an intent, the intent is installed, then I submit a new intent, probably changing a constraint or changing the priority, for example. The existing intent will first delete all the installables that are related to it, and then uninstall the new one. So this is a disruptive behavior, and we saw that this disruptive behavior is both in the flow rule and in flow objective installers. So now we'll present you what is our solution for conceptually what is our solution. So as you can see here, we have this green path that is currently allocated to an intent. Can be a point-to-point intent, for example. And what happens? I requested the reallocation for the intent. The intent, of course, should be the same key as the first one. So we mean that this intent with the green arrows is the intent with key number 1. So what happens? I requested the reallocation. I compile the intent, the new intent. So before, so I install the intent, the new path, sorry, with a lower priority. So in this way, the traffic will continue to flow through the green path, and the orange path now is going to be installed. Think about a very big network, and it can take time to be installed in every device. So in order to avoid any disruption, what we can do, we need a different stage of update. So we go to this third point, that is delete the previous path flow rule at the ingress point. So I have the path here, the flow rule, sorry, that says go out with to port number 2, and this can be port number 3. So I delete this flow rule, and automatically the device I tested with OpenMoveSwitch this configuration will start to, the traffic will start to flow in the orange path. But why don't we delete automatically all the old path? Because it can happen in very big networks that we can have a delay from the packet that starts here and the other packets that are currently flowing inside the path. So I deleted only this rule in order to avoid disruption of any packet here. So here we come to this fourth step. So I deleted the path, but I have two possible options to delete it. One that can be the easiest one is I wait for a configurable amount of time. So for example, 1 second, 5 seconds, in order to be sure that there won't be any packet this is currently flowing here. Or more safe system, but is more difficult also to be applied, because also I started to develop this feature, and when you deal with statistics, it can be really difficult, because also the user can change the amount of time that ONOS checks for the statistics inside the device. So the safest way can be to wait here in this device, check all the flow rule if it has no more matches, and then delete all the path. So since I installed the path with a lower priority, I need to restore the path to the initial flow rule priority. This operation is it can be straightforward with the flow rules without problem. So how we can implement this in ONOS? So our modification proposal is to add a new intent service API, and we add this reallocate API, and we can submit a new intent. There can be also not only intent that are related to path, so I mean path intent or link connection intent, but also not to host intent with a different constraint. Because if I submit to the current API, I have the disruption. Also, think about to change only the priority. This can be a really simple and easy thing to do, but it can have a disruption in the. You can have a disruption of the service. Why also need not implement this in the current submit API that is already in the ONOS intent service? Because when you have to deal with optical devices, the reallocation can be also somehow can take a lot of time, because you have to create the light path before allocating the new service in the electrical AP and MPLS layer. Then what do we think also that we are going to implement this inside the intent manager, but there are really few modifications. The most important part that should be modified is the intent installer, because you have to check inside the intent installer what are the installables that are going to be submitted to both the flow objective and the flow rule installers that are already there, and handle all the different stages of installation. So then we can add these. We can add this to the intent stage, so the relocation request and the relocating, and then we have to, in the intent installer class, we modify the behavior when we have the flag relocation request. So this is my last slide. I'm open to your question on dApps.
Thanks,
So
Antonio.
I have one question. Go ahead.
No, go, please.
So yeah, my question was, why did you decide? Did you think we need to introduce a new API for it? I mean, update. We could change the update behavior to this kind of thing. So is there something like missing parameters, so on, that will make it impossible to do this kind of non-disruptive update using the existing intent? That is, using pushing intent with same key.
Okay, I understand your point. Because I think that these two functionalities should be separate. Because when you update an intent, as I said before, when you deal with optical connections, you should do it can be a cost for an operator to create a light path before and then migrate the traffic. So this is why you can, in this way, make the application developer or every service that use the intent service free to choose if do a disruptive or non-disruptive relocation. But this is my opinion. I don't know if there are other ones.
I see. I kind of feel if they are willing to go with cheap paths where they are okay with disrupting, and we could do the similar existing behavior, simulation of this existing behavior by simply removing existing intent and installing new intent, and up or something like that. So I thought, to not to complicate things, I mean, just change the existing install behavior and so on might be simpler, but I haven't looked into that in much of a detail.
Yeah.
Yeah, I think I'm sort of on the same page as Utah. I think having sort of either a global parameter, configuration parameter that could be set, which is sort of disruptive or non-disruptive. If, for example, it's going to be on a an operator by operator basis. If you really think that it'll be on a per customer by customer basis, then I mean, we could consider it, but I think you have enough information, and maybe with just a simple constraint or additional parameter in an intent, we could potentially carry the information required to sort of implicitly decide whether to reallocate or reallocate disruptively or non-disruptively.
It could be a solution, yeah. Yes.
Probably the external API we can probably preserve it, but internal API we may need to do something like previous intent data and the new intent data in parallel and pass that down as a context so that whatever intent installer can know the previous state and so on to do whatever clever stuff. So
this is a really good idea because, for example, you can implement your own logic in your intent installer if the intent installer will be pluggable. So this is a really good idea. You're right, Utah.
So just a comment on, can you go back on slide, I believe, 3, I guess, well, or 4, sorry.
This one?
Yeah, just a comment on the alternative between the deleting options. I'm not sure B might be the best, but I'm quite sure that if you can avoid A would be good. the reason is that in general, I have the feeling that every time we end up to use timers in ONOS, something screws up. Timers are really evil. We should avoid timers in my mind all the time we can. So yeah, if you find a better condition to delete that stuff, I strongly suggest you to don't go with A. I understand that you have it now for the time constraints you have for your demo, but for the final solution, don't go with that if you can.
Yes, of course. Yeah, the only problem of B is that it can be...
Sorry, Antonio and others. Can you please share the link of these slides, because I came late and I didn't follow from the beginning. So if it's possible to share the link in the chat, please.
Yes.
Okay, thanks.
Okay.
Also, thanks for joining, Abdulrahim. We had a shout out to you earlier in the meeting for your work with the Teaching Brigade. So thanks for doing that.
Thank you.
Nothing, Brian. Thanks for you.
You.
Okay. So you can.
So Luca, do you have any suggestion for the solution related to the point 4 here?
Well, I mean, I just believe for now that between the two, B is better than A, but say that Brian or others might have even better suggestion than that. I'm just saying I would avoid to go with A. That's it.
Okay.
So I also was going to make a comment here, and the comment is I agree with you that the waiting for the flow rule stats and polling and sort of doing that mechanism is kind of expensive and will probably require you to keep the rules on devices for longer than they need to be, because it can take some time for the stats to be pulled. But something that we should be able to do, and this is kind of a tangent, but we should be able to figure out what the maximum latency is on a given path. If we understand what the propagation delay is between devices, what the maximum queuing delay on devices is, and also the maximum time to install rules, we should be able to, create an upper bound on how long a packet could possibly be in the system. And so if we were able to, on a per path basis, compute the maximum latency, that you could just use that as your as the timer that you use to remove flows. And it's still a timer-based solution, but it's a timer-based solution that is bounded, in some amount of math rather than just an arbitrary configured time.
It's more dynamic, sure.
Yes, but do you have any subsystem in ONOS, to provide the evaluation of the latency among a path?
So we don't do that today, unfortunately. I think it's something. It sort of borders on things that ONOS could be doing in terms of like in-band network telemetry. But yeah, if we had such an API in ONOS today, or if we were to develop one in the future, I think that would be a good mechanism. And if there was an assumption that at some point in the future we'll have some mechanism, then using a static timer for the initial portion of your work, and then changing that to an API call some point in the future could potentially be a viable strategy, just so that you can make progress on this.
Okay, thank you very much.
I'm not suggesting that someone is working on this or it's a priority for someone, but it's a possibility. And if we wanted to pursue this approach because we realized that B was going to be impractical, then we could try to advocate for someone in the community to try to do the work of computing maximum cost or maximum latency for a path.
Sorry, Brian, but well, assuming we are using OpenFlow, how would you expect to do that? Well, my point is either we do that from the controller, from ONOS.
Right.
It means that one packet would need to go up to, well, some kind of messages should go up to the controller, right? But still, I don't have a way today in OpenFlow, well, I think, on top of my mind, to say the packet arrive on this switch at this time. And by the way, at that point, the time is always measured by the switch, which is a distributed thing, which will have, if we need to measure milliseconds, which will have a different time from the other switch. So I don't see the need thing, right?
So there are certain pieces of this puzzle that could be sort of done piecemeal. And really all we're doing is we just need to create an upper bound, right? If the actual time in the maximum is 1 second and our computation yields a result of 2 seconds, well, there's some overhead to that, and that overhead is going to be extra flow rules on devices, but there's not from a functional perspective, not a loss. So as long as we can establish a reasonable upper bound, that could be done. For example, if you knew what the maximum propagation delay, so like the speed of light latencies on all your links added together, plus the maximum queuing delay, plus the maximum rule insertion delay on the devices. If you just summed all those latencies together, you'd have a reasonable upper bound for a given path. And go ahead.
Okay.
And so you could compute the propagation delay on a link by link basis. We could do that in the link detection service. By just pushing our LLDP messages in and waiting until they get back. Yeah, there's some extra latency in there, but it would give us a reasonable upper bound for the propagation delay. The queuing delay you could do on a device by device basis, or just use a reasonable estimate. And then the link installation delay again could just be a reasonable estimate, and it would be kind of rough math. It wouldn't be good for figuring out what the actual delay is. But again, we just need to have a sort of an algorithm for determining a reasonable upper bound on a case by case basis, such that you don't have the situation where the static or configured timer is less than the upper bound on a given path.
I agree there. I mean, Antonio brought up light path as an example. I mean, in that case, we definitely cannot rely on the packet counter, so we should compute some kind of upper bound and assume the old path is clean or something at some time.
The only problem that I see here about the delay is not the computation itself, but as if I correctly remember, Brian said about the timer. So we are going somehow to give a timer in this task. So when we have to delete the path, we should submit somehow a task that will do that in 500 milliseconds, 1 second, and so on, based on the delay. So we are working with time.
Or it can be even a very long process. So let's say hours. So something like that you reallocate the path when you are sure that all the statistics are not more, that flows, the previous flows has not been any more used. So, I mean, reallocation is not done every day in real network. You do it sometime, and then you can also wait some hours before reconverging your network, I guess, but I don't know.
Yeah, I guess the only downside to this is why I said reasonable upper bound, right? Because if it's perfectly acceptable to have 2x overhead on your flow rule tables because you have lots of rules that you don't want to deal with for hours or days, then yeah, a reasonable upper bound would be like 2 days. But if the 2x penalty on rule flow table space overhead is not acceptable, then a reasonable upper bound would have to be a smaller value.
Yeah.
Yes.
And from a technical perspective, really what you're trying to do with this with this algorithm or this heuristic is just figure out when it's no longer possible that a rule could be using these particular flow that a packet could be using these particular flow rules. So, I mean that the only reason, I think we're diving into the or we're going over this is because it's possible that if you had a really deep queuing buffer or you had a really long links, that packets could be around for a long time, and it may not be worth it to pay that 5 seconds or whatever it's possible to be in all circumstances, especially if there's pieces of the network that are going to be much lower latency.
Okay. So we need to think about that and find a possible solution.
I think that we can somehow start working, of course, on the timers, and then we can interface with this possible API in the future. So it can be a possibility, I think.
One more little comment about this current slide. So we install the new path with lower priority, but is this strictly necessary? I mean, if we keep updating the flow, the priority keeps going down and down, and at some point we reach no alternate priority kind of situation. I mean,
but you restore it. In point 5, you restore the initial priority.
Yeah, but the problem was the main problem that we thought was that if we install the path with an higher priority, it can happen that not all the flow rules are installed inside the devices if you have a very big network.
All right. So I don't remember the current state of the code, but I thought we had phased installation where leave out the head end, and install the rest in parallel. Then once they're ready, install the head end kind of thing. And if we could do that, I mean, then it should be possible to only modify priority on the head end, and the tail of the flow can be installed in the final form in the first place.
Okay.
On the same vein, it's possible that, I mean, in this picture, there's no overlap in the paths until the egress node, but it's possible that there could be overlaps in path before the egress node. We'd probably also need to detect those overlaps, because, for example, if you lower the priority of everything, it's possible you'd redirect it for the initial part of the path, but then if there's like one overlapping node and then it goes off in another direction, it's possible that the lower priority rules for the new path would get lost, and traffic would prefer the old path.
I saw that this thing that you are saying now, you can somehow check with the device ID. So you have one rule that has a different treatment for a device. You know that this device is going to be one, you will have one rule with a lower priority that goes on another direction, and the old one that is here with the current priority. So you can work with the device ID in order to understand what are the overlapping, and then update the one that are overlapping. So if you have a path that is
not overlapped, you update only the one that are not overlapped.
Now I think about point number 3. So when you delete, so when you change.
So, exactly. So okay. So you delete only the one that are not overlapped, or that are
the one that are overlapped before number 3. Then
if you have already some path that is
think about if you have I don't know, here another one. Okay. So another topology like this that is attached here. Okay. So you have this overlapping, this overlapping. Okay. You have 2 rules that are installed here and here. So I think that it can be safe to change this rule or delete this rule is in our solution, delete this rule and this rule when you do the change of path. you will not have problems because you have already a rule here that can forward the traffic in the correct way.
Sorry, I'm trying to put together a picture really quick to maybe explain something. 1 second. I'm going to put it in the TST meeting notes. The link is in the chat, and I'll share my screen in just a second. Or you can share it too. 1 second. So,
yeah.
You see the drawing now?
Yeah.
Yes.
You have the red path is the original path, and the blue path is the new path. It's possible that you could share a device later in the flow. And in this case, if you made the blue path lower priority, traffic would go through the red path the whole way. And then if you changed the initial device, device 1, to delete the rule for the red path, the traffic would follow the blue path to the middle, and then it would continue on the red path because the blue path is still lower priority.
But it depends, because here you should have the import, so the import should be different. So the matching is different.
Okay. I mean, I think you could construct, you could make the topology more complicated. You could take this middle device and make it 2 devices where they do share one link, for example. Let me do that.
How you can share a link?
I'll show you this in a second. Okay, this one.
I think Brian want to say if you have a shared bottleneck, let's say, shared link between 2 switches.
Right.
So both links will pass through the same
Okay.
2 switches. So in that case, yes. Now you can see the design now. I think this is the idea.
Okay. Now I get it. Okay.
Something like this, yeah, where you have a shared bottleneck link and shared bottleneck device. Now, if you did encapsulation, and the encapsulation sort of key or encapsulation value, the VLAN or MPLS label or VXLAN or whatever, was different, then as long as that was getting pushed on and pulled off at the end and the beginning, you'd be okay. But if you were just going to use the traffic selector that was provided by the intent, it's possible that you'd have this overlapping problem. So we don't need to have an answer for this right now, but it's, I guess, just something to think about in as you continue to think about your design.
Yeah.
Yes.
May I ask a question as well, please? It's just to learn now, because I'm not aware on all this project. But I think that here you abstract the routing decision. So you suppose that, okay, we will change the path. And if we want to change the path, what to do to remove the old one and to install a new one without disruption? But the question is how to make the decision of routing. How do we optimize, in fact, the routing, let's say, inside the network? So do we consider another application that collect information, I don't know, let's say via BGPLS or whatever, and later calculate a new route based on, let's say, a new metric, and then using this, let's say, intent reallocation to install a new path without disruption? Or do we have another, let's say, project in the future to do that? I don't know if my question is clear or not.
Yeah, Abdullahim, this is Luca. So I guess what these guys are doing is quite transversal to these mechanisms, in the sense that in this case, when you install an intent, you can specify a key which identifies that intent inside the system, inside the cluster. So they're just proposing, well, they are proposing to, you know, when the same key is used however is used, to just don't create, don't be disruptive in the user traffic. So, but this is not really directly related with what stays above. So usually what decides these mechanisms we were talking about, what provides these mechanisms is the application above.
Yes, okay, I see.
Okay, so in this case, for example, VPLS does that, right? So if, this is just an example, just because I know it. We install the first VPLS with a set of intents that have a key, and then the VPLS can change over time for many different reasons, which are not, in my case of VPLS, really related to bandwidth or other stuff. It's just because the user reconfigures the network, right?
Yes.
Which might be for different reasons. And in that case, we rewrite the same, well, a different intent that has the same key. So in that case, right now, that would be disruptive for the end users.
Yes,
right?
yes, I see.
Because we just delete the related flows and we install new flows. So with these modifications,
absolutely, the idea is very interesting. In fact, it's really a very good point.
but I see your point as well. I mean, it's something. It's up to the application for now.
Yes. Yes, I see.
So, Antonio, I have just one more logistical note this time. Since it seems that this is still, it's work in progress, I just suggest, if you can, to share just, the design documents or whatever you have with the Northbound Brigade. So Michele is inside already. It doesn't mean you have, once you write to the brigade, it doesn't mean you have to commit to something, you have a timeline. I'm just saying it's a group where you have a bunch of people that are usually working and interested in the Northbound and in the intent framework, right? So they can provide lots of suggestions. They should be also automatically also in ONOS Dev, the same people. But it's not a big effort, I believe, to add one more recipient in CC, right? So I think it would be better for you.
Yeah, for me it's okay. There's no problem.
Okay, any other questions? All right, thank you, Antonio, for dialing in and presenting this. I think it's really interesting stuff, and like Luca said, if you want to share this with the Northbound Brigade, hopefully, we can coordinate your efforts with some of the efforts that they have on some of the enhancements they're working on.
Yeah, because starting coding, so yeah, it's going to be important to have clear the ideas before.
Yep. And if there are some of these topics, for example, the changes, whether the API changes are required or whether we can do something else, and the overlapping paths, the priority stuff, it would be good, if you wanted to continue to think about them or have a conversation on the mailing lists about them, we could probably work towards resolving those outstanding design issues.
Okay, thank you.
Okay. Does anyone else have any other comments for the general meeting? General TST? Okay, well, I guess with that, we could probably call this meeting to a close. Thanks everyone for joining, and we'll see you next week.
Okay, bye.
Many thanks.
Thank you, bye.
Bye-bye. Bye.